Imagine you're working with two Omron NX1P2 PLCs, and you need them to communicate efficiently. You're faced with a crucial decision: should you use EtherCAT or Ethernet/IP? The stakes are high because the wrong choice can lead to unnecessary complexity or even system inefficiencies. In this scenario, you're dealing with a system where the main machine must operate autonomously or be supported by a secondary power unit. The goal is to exchange just a few words of data between these PLCs. The challenge lies in selecting the most straightforward and effective communication protocol. And here's why that matters: choosing the right protocol not only simplifies your development process but also ensures optimal performance and reliability of your system. Let's dive deeper into the protocols available for your Omron PLCs. When choosing between EtherCAT, Ethernet/IP, and standard Ethernet, it's crucial to understand their distinct mechanisms. EtherCAT is a high-speed, deterministic protocol ideal for motion control applications where precise timing is critical. Ethernet/IP, on the other hand, is widely used in industrial automation for its robust communication capabilities and support for complex data exchanges. Standard Ethernet, while less deterministic, offers simplicity and flexibility, making it suitable for general data transfer tasks. Imagine EtherCAT as a high-speed train, Ethernet/IP as a reliable bus service, and standard Ethernet as a versatile car. Each has its place depending on your specific needs. Now, considering your scenario with Omron NX1P2 PLCs, standard Ethernet might be the most straightforward option for exchanging a few words of data, given its simplicity and lower overhead. However, if you require precise timing or are dealing with motion control, EtherCAT would be the superior choice. For general industrial automation tasks, Ethernet/IP offers a balanced approach with good performance and reliability. To start, let's dive into the initial setup for using standard Ethernet for communication between Omron PLCs. Begin by configuring the network settings on both PLCs. Ensure each PLC has a unique IP address within the same subnet. For instance, you might set one PLC to 192.168.1.10 and the other to 192.168.1.11. Next, utilize the cpconnect function to establish a socket connection. This is your gateway for data exchange. Once connected, employ cpzen to transmit data and SKTT-CPRCV to receive it. Remember, the data format and size must match on both ends to avoid errors. If you encounter issues, verify the cable connections and check for any IP conflicts within your network. And here's a pro tip: always test with minimal data first to ensure the connection is stable before scaling up. Now, let's dive into the practical execution. To establish communication between your Omron PLCs using standard Ethernet, you'll need to implement specific code logic. Begin by opening a socket using the cpconnect function. This function initializes the communication channel. Next, use cpzen to transmit data and SKTT-CPRCV to receive it. Remember, these functions are part of the library designed for this purpose. For the wiring, ensure both PLCs are connected to the same Ethernet network. There's no need for complex wiring beyond standard Ethernet cables. This setup allows for straightforward data exchange without the overhead of more complex protocols. And here's a pro tip: always verify the IP addresses of both PLCs to ensure they're correctly configured for communication. When debugging communication issues between Omron PLCs over standard Ethernet, it's essential to understand the common pitfalls that can arise. First, ensure that your IP addresses are correctly configured and unique across the network. Incorrect IP settings are a frequent cause of communication failures. Next, verify that your port numbers match on both PLCs. Mismatched ports will prevent data exchange. Another common issue is firewall settings. Ensure that the necessary ports are open and not blocked by any security software. Additionally, check the cable integrity and network switch configurations, as physical layer issues can often masquerade as software problems. Lastly, always confirm that your PLC firmware is up to date, as outdated firmware can lead to compatibility issues. By systematically checking these elements, you'll significantly reduce the likelihood of communication errors.